Hey guys, welcome to Amra Backbenchers. Today we will discuss the stability of a system. For an LTI system to be stable, it must satisfy two conditions. The first one is, for any bounded input, the output should be bounded, and the second one is, if the input to the system is 0, the output must be 0 irrespective of all initial conditions. We will find the stability of the system by using Routh Hurwitz Criterion. So what are the purposes of Routh Hurwitz Criterion? We can find the stability of a closed loop system. We can also find the number of poles in right hand side of the S-plane. That means we can find the number of poles in right hand side of the S-plane, left hand side of the S-plane, and on the imaginary axis also. We can find the natural frequency also by this method and the value of k for which the system is stable. Now, one disadvantage of Routh Hurwitz criteria is we cannot find the exact location of the pole. Means we cannot say the pole is in -2 or -1 or -3. We can only say that the pole is in left hand side or the right hand side. So for finding the stability, we need to first of all we need to find the characteristic equation. Let us take a transfer function like this: k by s cube plus 6x square plus 4s plus 4. So here the characteristic equation is the denominator of the transfer function. Here the nth order general form of the characteristic equation is shown. It looks somewhat difficult, but while solving problem we will get to know that it is not at all difficult. The necessary condition for this is all the coefficient must be present and all of them should have same sign. So what does it mean? All the coefficient must be present means if the highest power is s power 3, s power 2, s power 1 and s power 0 must be present in the characteristic equation. If the highest power is s power 4, s power 3, s power 2, s power 1 and s power 0 must be present in the characteristic equation. And all of them should have same sign means all of them must be positive or all of them must be negative. This is the tabular form of the characteristic equation. Now we will understand this form by taking one example. Here the highest power is s power 3, so s power n is this one. Here the coefficient is 1 and 15, 20 and 180. So a0 is this one, a1 is 15, a2 is 20 and a3 is 180. So now we will write in this manner. Here Sn is S3, Sn minus 1 is s power 2, s power 1, s power 0. So we will write in this manner a0, a1, a2, a3. So how we will write? 1, then 15, then 20, then 80. If there were some other coefficients, then we have to write in this manner. This one is a3, then a4, a5, a6, a7 like this. Now how we will write this coefficient? Until this one we will write the coefficients from the characteristic equation. After this two row we will calculate the coefficients. So here what it will be here? It will be 15 into 20 like this, 15 into 20 minus 180 into 1 by 15. So the result of this one will be 8. What will be here? So how we have written this coefficient here? a1 into a4 minus a0 into a5 by a1. a1 into a4 minus a0 into a5 by a1. So here it will be 15 into 0 minus 0 into 1 by 15. So it will be 0 here. Now if we assign this as p and this one as q, what will be the coefficient here? P into a3 minus a1 into q by p. Here it will be p into a3, p into a3 minus a1 into q, a1 into q by p. So here it will be 8 into 180 minus 15 into 0 by 8. So it will be 180 only. Now we will solve some problem to find the stability of the system. So we will write in this manner: S4 S3, S2, S1 and S0. Here the coefficient is 1. So this one is A0, A1, A2, A3, A4. So we will write here 1, 2, 3, 4, 5 and 0. A0, A1, A2, A3, A4, A5. So how to calculate the coefficient of this one? This into this minus this into this divided by this one. So 2 into 3 minus 1 into 4 by 2. This one is 1. Again for this coefficient, 2 into 5 minus 1 into 0 by 2. 2 into 5 minus 1 into 0 by 2. This is 5. And for this coefficient it is 2 into 0 minus 1 into 0 by 2. So this one is 0. For this coefficient we have to multiply 1 into 4 minus 2 into 5, means 4 minus 10 by 1. It is minus 6. And for this one it will be 0 and 0. Again for this coefficient, minus 6 into 5, minus 6 into 5 minus 1 into 0 is 0 by minus 6. So it is 5. So we have to count the number of sign changes. It is the main condition to find the stability. The number of sign changes in the first column. If there is any number of sign changes in the first column, that means the system is unstable. And if there is no change in the sign in the first column, then the system will be stable. So how many sign changes are there? It is positive, this one is positive, this one is also positive, here it is negative, and again it is positive. So the number of sign changes is 1 and 2. Number of sign changes is 2. By this number of sign changes we can tell that number of pole in right hand side of the S-plane. Is 2. The total number of pole in this equation is 4. How we can find the total number of pole? By seeing the highest power. The total number of pole is 4 and the number of pole in the right hand side is 2. So the number of pole in the left hand side will be 2. By this we can find the stability. Here the system is unstable because there are some sign changes in the first column. Let us move to the next problem. Again we will write in the similar fashion: s power 4, s power 3, s power 2, s power 1, s power 0. Here again the coefficient is 1, 1, 2, 3, 2, 1, 0. For this coefficient, 3 into 2, 6 minus 1 into 2, 2 by 2. It will be 4 by 2 equal to 2. For this one, 2 into 1 minus 1 into 0 by 2. So this is 1 and this one is 0. For the coefficient in this place, 2 into 2, 4 minus 2 into 1, 2 by 2. So it will be 1. For the coefficient in this place is 0. 2 into 0 minus 2 into 0 by 2 is 0. Now the coefficient in this one, 1 into 1 minus 2 into 0 by 1, it is 1. So how many sign changes are there? Positive, 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 positive and positive. There is no sign changes, means the system is stable. First of all we can say that the system is stable, and the number of pole in the right hand side is 0 because there is no sign changes. So all the poles are in the left hand side. The number of poles in the left hand side is 4. Here the total number of poles are 4. So the number of pole in the left hand side is 4. So friends, we will see some more problems in the next video. Do like, comment, share and please subscribe to our channel Amra Bank Ventures.